Well, hi there. This is Matt Genovese from Panorama Labs. I've been looking at generative AI for quite some time, going back to GPT-2 and then 3, and of course 4 is out right now. I've been looking at it for lots of different things, right? But code generation has been really interesting to see how that plays out. GPT-3 and then 3.5 Turbo, which is known as ChatGPT, is done really well. GPT-4 is really showing a lot of promise. I've kind of always been interested in from an HDL point of view, and I haven't seen a lot talked about on this front. And so I thought I'd make a video for what I found out so far. I'm going to be looking at GPT-4 right now, and we'll give it a try for doing some Verilog code generation, and we'll see how it works out. Or I should say HDL generation. So the first thing I've got, as you can see here, I have OpenAI's prompt interface open. So this is the web API or the web version. By the way, this is all live or recorded on the fly. So we're going to see how this plays out. First thing we're going to do is make sure that we're in chat mode, which we are. I'm going to set it over to GPT-4 because why not? And then I'm going to set the temperature down. And when I've done this before, I put it around 3. Basically, the higher it is, the more creative it is. And for some of these things, I don't need the creativity. I really just want it to do it right. I'm not looking for poetry here. The length here, I'm going to go max it out at 2048 at 2K. The rest of these, I've been able to leave the same. So I'm going to copy and paste in some things here. First of all, you'll see that this is new as of GPT-4. They started doing this where you have this kind of system prompt on the left where you're kind of giving it the expectation for what you're going to be doing and how it needs to behave. So I'm going to paste in what I used before. Basically said, look, you're a senior chip design engineer and you're an expert in Verilog and designing microprocessors, because we're going to play around and see if we can get it to design an ALU. And then I'm going to put in the prompt. And again, instead of having to type all this, I'm going to just type it in here or paste it into here. I typed it in before. So you are aiming to build an ALU with the following specs. So we're going to have 8-bit input, 8-bit output. So therefore, we're not going to do any multiplies or things like that. We're going to have a carry in, carry out. And we'll have the basic Boolean operations and add and subtract. And then we're going to write it in behavioral Verilog. And I did specify behavioral Verilog, and let's see what happens later on if we go to something different. So with that, I can just click submit, like that. And like the chat versions typically do, they will write information about what they're doing and then give you the actual code itself, and sometimes even provide explanations. By the way, if we did not set the maximum length here to 2048, it would have probably cut out already and not been able to finish it. So that's why you have to extend that out a bit. So here it wrote it. It looks pretty good. I didn't specify the opcodes to use, so it's using 3-bit opcodes, which is just fine. And it's doing it, what is it, 00011011. Okay, so it's doing it in numerical order, which is just fine. Wrote behavioral Verilog for it. And then it gave undefined operations. Interesting. That was an interesting choice. And there we go. So what we can do, let's just, for the hell of it, let's try to compile it. So you can go in here and select, which is what I'm going to do. We don't need the Verilog. This is just kind of telling it that if it renders it, it can render it as Verilog. It gives a hint to any code rendering engine, but we don't want to copy that. And so now I'm going to paste this over here, and I have a Linux box, or my own Linux box here open. I'm going to do an experiment here. I'm going to paste it in. I use VI because I'm old school. And there. Now we'll just use Icarus Verilog and see if it compiles, which it does. Now, it doesn't really help us. A.out's not going to give us anything, right? Because we're just looking at, there's nothing to show. There's no display statements, right? So let's go back and try, all right, let's give it a try and say, maybe write a test bench for us, right? I used to work in design verification, so pretty familiar with the whole idea that we need to test it. If you don't test it, it doesn't work. So I'm going to put in a prompt that again, a follow-on prompt. And the nice thing here, if you're not familiar with ChatGPT, is that it will use the context of your conversation as part of the responses going forward. So I don't have to refer to what we just did. I can just say, hey, write a test bench for me, which is what I'm going to do. Write a test bench. And let's go. All right. I'm scrolling up here real quick to look if, well, okay, I can't do that yet. I'll just let it go and, right? So it used a monitor statement. That's good. So it'll show the states. Okay. So it's monitoring. I wanted to make sure it's actually pulling in the ALU, the module name correctly, which it is. So it used the module name of the DUT. And look at that. Okay. Let's give it a try. So now we're changing. We're looking for, okay, well, let's give this a try. So what we'll do is we'll copy and paste this the same way we did before. Oh, it used the time scale. That's interesting. All right. In module, we're going to jump over here. We'll drop this in. And now we got to do iVerilog ALU.v and ALU test.v. Now we can do it a.out. All right, so it's giving us the opcodes that use, or I forget which ones they were. What were they? The opcodes were, oh, it even gave a list. And or XOR, okay, so and, yeah, that's right. Or, that's right. XOR, yeah. Interesting, it's keeping the inputs the same. And then what were the rest of them? Invert. And, all right. Add, okay. I think it got the carry right too, did it? I'll have to go back and check. So anyway, what we're seeing here is that it did a pretty good job of generating, and this is GPT-4, and I've tried this on 3.5 and back on 3, and it would make mistakes sometimes, but it's getting a lot better, and I'm been pretty pleased with it. Now, I mean, we haven't done anything with clocking yet, and this is kind of a basic intro. We want to really just see, hey, look, what can GPT-4 do when we're generating Verilog? You know, can you go in and try to generate a RISC-V processor from this? Not quite yet. But look, we're at a very nascent period right now in this whole process, and it's kind of exciting to see what it's able to do. So one more thing I'm going to do here, I'm going to jump over and I'm going to grab this last prompt, because I wanted to try this out. And this was actually something I wasn't planning on including until I tried it earlier, and I thought, oh my gosh, it kind of works. So remember, we asked for it to do behavioral Verilog, which is what we have here. So it's using always at, it's using a case statement, right? And so I wanted to say, well, what if we took this and implemented it in structural Verilog, right? So, and I'm just going to call it, I'm going to call the module ALU struct just to keep with the capital that it chose. I use the word synthesize, really it would just mean transform. I'm not trying to make this into a synthesis engine at all, but I wanted to see what would happen. So let's give it a try and see how this works. Oh wow, it even tells me, okay, it's synthesis tools, not for the likes of GPT-4, but it is going through. Oh, interesting. Okay. So it defined a full adder. Okay, so it's got carry in, carry out, and then it's, huh. Okay, So what did it do? It made a full, oh, it's giving you an example. It's giving an example of taking a full adder and then creating the inputs, outputs, using generates, and instantiating the full adder. Oh, I see. They're making the adder itself. Interesting. Okay. So this is, okay, very good. Well, one more thing. Let's just give it a try. I used to work, when I was in verification, did a lot of work with SystemVerilog Assertions and informal and simulation-based testing. So I'm really curious if it can add some SVAs, how much knowledge it has about SVA. Let's give this a try. This is, by the way, this is the fun with GPT-4. I mean, you can use GPT-4 for lots of different fun. For me, this is interesting to see, what it can do. What are the limits of what it can do? And that limit, by the way, is a temporary one, because I think it's only going to get better with these capabilities. So let's give it a try. We'll say, thanks. Always tend to be polite. Thanks. Let's add some SVA. I'm going to spell it out. SystemVerilog Assertions into the, I'm going to say the original behavioral Verilog. Or formal checks. Now, I don't recall if if Icarus Verilog will actually handle that. I believe it will, but I haven't done a lot of testing, so I'm not going to go in and do all of that. But here, okay, so it's actually rewriting. It's rewriting the module, original one, and I presume it will add in some SVAs. I think if I had, okay, I see. Oh, I see what it's doing. If I had specified it differently, it might have generated SVAs externally, which is something else that you can do. So here, okay, interesting. One thing I also have not tried is using SVAs or like on clocked networks, where it would actually have to go and look at so many clocks ahead of time, or look for distances in time for something to happen in the future. Like on a request acknowledge type of approach. That would be really interesting to try too, but that's for another day. So with this, it seems to be doing pretty good. I'm kind of impressed by this, and you might be too. So I may post another video later on. This is, again, all been focused on GPT-4. One of the other areas that I've been looking at is with using Copilot, GitHub Copilot. And it knows and can recognize and can generate, from what I've seen in my own little, like 10-minute experiments, it can generate Verilog. And so I almost want to kind of start with what it provided here and see how much I can do in say VS Code in Visual Studio, and with Copilot on, and see what it can do. So that might be another video, but until then, thanks a lot for watching, and I hope this has been helpful to you. You have a good day.